Hi, Mr. Ben.
Hello. Sorry.
Yeah, 1 second. Obina is going to join in now, and we're already asking everyone to join the meeting.
Okay. I'm trying to set up my camera. I don't know what's going on.
You're trying to set up what?
Okay, so good evening, everyone. Please confirm if you can hear me. Can you guys hear me?
Yes, we can hear you.
We can hear
All
you.
right, all right. So good evening, everyone. Welcome to another section of an EDTS workshop. For those of you that don't know me, my name is Obina. I'm the project manager and coordinator of EDTS activities. I wish to welcome everyone into a happy new year, everyone. So let me not beat around the bush and go straight to the point for what we have for today. So we're actually having an advanced data analytics course walkthrough with one of our finest instructors in the building, Mr. Okaben. You're welcome. Please don't forget, if you're a new member here looking to seek knowledge in data analytics, we're actually having our first training coming up on the February on in February, February 7th. Yes. So if you're looking to register and have a 1 month training on Excel, Power BI, SQL, and Looker Studio, please do not hesitate to actually reach out to the management, and don't hesitate to reach out to me or Jassy or Siska. And also, if you're looking to get hands-on training and experience on internship and our job readiness platform, on our job readiness program, do not hesitate to actually also reach out to me so that you can register and be a part of this section. Please be advised that we have limited sections. We have limited sections remaining. So if you want to actually register, you have to actually be on time. So let me not waste any of our time and let's get to the due day. Mr. Okeze, good evening, sir. You're welcome once again.
Thank you very much.
All right, sir. The floor is yours. You can carry on.
Okay, good evening, everyone, and I'm so happy to be here with you guys. Firstly, I want to thank you guys, every one of you that is here that is interested in this program. I really appreciate you guys for taking your time out to be here, at least putting a little bit of effort to learn something new or to upskill in your various walks of life. So in for today, I'll be presenting the advanced analytics data analytics class. And let me just share my screen right now. So I believe we can all see my screen. Can we see my screen? Are we seeing my screen right now? Okay, so thank you very much once again. Um, for this program tonight, first of all, let me apologize. I'm kind of came back late, so I'm very tired. And if I'm sounding a little bit, sluggish or unclear, just call me back and I'll go through whatever it is that I said. So for this class, I'll be introducing analytics engineering and what it is, why it is interesting for you guys that want to upskill in your data career to learn it, and what relevance it has in today's current world. So let's get into it. Table of contents will be introduction to analytics engineering, what analytics engineering is and why it is relevant today. I'll tell you very important topics that you have to learn in analytics engineering. These are very fundamental stuff. Without this, you can't move forward in it. The tools to learn, just a very brief exposure within the limited time that we have. And for the rest, we may not have time today, but hopefully, if you can see how to go through the remaining ones. So then again, because of time, I didn't properly prepare all these slides, but I'll do best with what I have. I'll probably just be speaking off my head in most cases. So an introduction and background story. The introduction is just more about me. Currently, I am a settlement analyst and I work in a bank. And I got exposed to analytics engineering sometime last year. I still I still can't remember how exactly I got into it, but I know I started from business. Like most of us, we all started from data analysis. Data analysis was the major entry points to the data career within all of us. And then I gradually shifted into learning business intelligence, and then gradually I heard about analytics engineering. And why analytics engineering piqued my interest above the rest was, how do I put it? It was the fact that you get to build something that isn't really native to people who do data analysis or business intelligence. But as you get into the class more, you get to understand exactly what I'm talking about. So first off, what is analytics engineering? To introduce it properly, the course did say advanced data analysis. So it's very important to know that it is very much of an advanced data analysis than it is data analysis itself. So it's more towards the data engineering aspect. So whenever I hear analysis engineering, it doesn't know going to be doing a lot of engineering, a lot of coding. That is the fundamentals. That is literally what you're going to be doing a lot in analytics engineering. So it's a discipline focused on building robust, scalable data workflows. So much English, but let me break it down. As a data analyst, you probably use Excel, you use a Power BI, you use SQL. Those are very introductory stuff that you hear a lot when you say you want to learn data analysis. They'll tell you, okay, start with Power BI, start with Excel, start with SQL, those three fundamental stuff. And what you're doing, if you've ever used Power BI before, you realize that first thing you usually do is you go and get data from somewhere. You go and pick up your data from who knows where, maybe Cargo, if you're learning. To pick up your data from Cargo and load it into Power BI. Then you start with your transformation in Power Query, you do your cleaning, you do all those things. You do your data transformation, you do your data cleaning, you do your data modeling within Power BI there, and then you now move it to go ahead and do some analysis and visualization. So what analytics engineering aim to do is the entire aspect of data modeling, data transformation, um, data modeling and data transformation primarily, right? It takes it out of the data analysis role and puts it into its own full-fledged role, right? So it's not like, as a data analyst, the analysis engineer is who builds who builds these data models. So the data comes from various sources into a single point, into a single platform, which is your centralized storage system, like a data warehouse. And then it is now used inside there. You model this data so that people at the end users, which are the data analysts, can make use of this data. So let me go on a little bit. Analysis engineers provide clean data sets, which is the most important keyword here, clean data sets to end users. The end users are our business analysts, our data analysts, our stakeholders, and the likes. Sometimes even data scientists, even in other cases, dashboards, and the likes. And they provide these clean data sets to end users, modeling the data in a way that empowers end users to answer their own questions. So let me go on. Now, I suppose talk about what analytics engineering is a bit more, but let me just go on to the most important topics, concepts, or theories that you have to learn in analytics engineering. And at the very top is SQL. we've all heard it over and over again. If you want to go into data analysis, learn SQL. If you want to go into data engineering, learn SQL. If you want to go into data science, any data role at all is going to require that you know SQL. You can't run away from it. That is very important. And secondly, you're going to have to learn data transformation and data modeling. This is the very key parts of analytics engineering, data transformation and data modeling. You can literally work in a company and this is what you do 24/7. You model their data so that end users can make use of it, right? And lastly, understand data warehouse concepts. I can't underplay how important data warehousing is in analysis engineering, and I'll get into it in a moment. But if I were to explain it clearly, one reason why analytics engineering came up as a role is because in this modern day and age, a lot of companies are migrating from on-site data infrastructure into the cloud. So the cloud storage for data is mostly referred to as a data warehouse and sometimes a data lake. Some companies use data lakes, but the majority of companies use a data warehouse. And these companies, they get a large amount of data from various sources and store it directly into their data warehouses, right? They could have one, they could have multiple, but they get it stored directly your into their data warehouse, which is what they refer to as extract and load concept. So they extract this data from various sources and load it directly into the data warehouse. Why this is different from the traditional data engineering concept is that data engineers, especially back then, they usually go through the extract and transform route because back then storage was not cheap and they couldn't afford to just load vast amount of data into their storage. But now with the advent of data warehouses, storage has become very cheap that almost any profitable company can have their own data warehouses and have their data stored within this warehouse. So over time, companies have been generating data and be storing into their warehouse. And eventually, they need to make sense of this data. If you're a data analyst, you use Power BI, you can't just connect to various warehouses because the way Power BI works is you can connect to warehouses, but then again, you can't perform advanced modeling and transformation within Power Query, right? At the level at which analysis engineers perform theirs. So that is why engineering became an entire discipline on its own. So topics to learn: SQL, very fundamental. Data transformation. The major tool in data transformation is DBT, Data Build Tool. Hopefully, if you've heard it, well, I'll get more into it as time goes on. But if you've not heard it before, DBT is the primary tool analysis engineers use, and under that tool is SQL. So DBT is a layer on top SQL. The SQL was used to build DBT. And then lastly, your data warehouse concepts. Three very important concepts for you to start with to build your foundation as an analytics engineer. Okay, so these are the tools in just a non-exhaustive list of the tools. Some images didn't show, so I'll just right here you have your data transformation tools, which is DBT, and second supposed to be SQL. Your most important, above everything, you need to be practicing SQL the most, right? And practicing DBT. They are very important tools. You can't do away with these tools. Then at the left-hand side, we have ingestion tools like Airbyte. We have data warehouses like BigQuery. We have BI tools like Looker Studio and the Power BI that you use. And at the far end, we have data orchestration tools, which step into more of data engineering side than analytics engineering, but is always additional bonus skills to learn and have. So before I go on, if you have any question, if you have anything to clarify about anything we've gone through so far, please let me know, just signify and I'll answer. No question? Okay, so let me go on. So it's always important to know, if you've not understood what analytics engineering is, it's always important to know what it is and what it is not. So a lot of infrastructure building, people, you might hear building ETL pipelines in analytics engineering, which is very important. You might hear being able to build a pipeline that ingests data from point A to point B, but those are more of lesser complex stuffs than data engineers do. So data engineers are the number one here. It's not data infrastructure engineering. Those are primarily data engineering roles, right? So if you're confused on what data engineering roles and how it differs from analytics engineering, know that data engineers, they tend to build the very infrastructure of software, right? The data infrastructure of software, while analytics engineers come to pick up data from these platforms that have been built. So you could have Shopify, for example, which is one example I like to use the most. Shopify as a platform has been built by software engineers and data engineers. You know, at the infrastructure level, data engineers have built their entire pipeline for the Shopify platform to work. Now, at a higher level, business owners can come in and create their own Shopify stores. A single business owner can have multiple Shopify stores within multiple countries, but they don't necessarily need to have a data engineer to pull data from these separate stores and pull it into a data warehouse for them to make, because they need a centralized platform to make sense of their data from different places, which is where an analytics engineer come into place. We go into their separate Shopify stores from different countries and pull in data from the relevant data for them to make use of. And we pull it into a data warehouse, and from there we carry out our data modeling, our data transformation, and the likes. So it is not, secondly, it's not primarily about building dashboards. That a lot of data analysts do that. They go into building dashboards with Power BI, but that is not the focus of an analytics engineer. We focus more on the transformation and the modeling, and after that, we hand over this data set, this prepared data set, to data analysts to make use of and analyze and make sense of the data at the user end. So next is not just SQL. So SQL, when you're learning SQL, you tend to use SQL for a lot of queries in the database, but analysis engineer tends to focus on writing reusable SQL scripts that can be packaged as programs, right? If you go hands-on into the program, you understand this concept a bit more. You understand it more than how I can explain it here. So you have to do things like version control, documentation, testing, and the likes, which takes principles from software engineering and apply it to data analysis, apply it to the data analysis discipline. So which is why it's referred to as analytics engineering. And lastly, it's not a purely data analysis role, right? So you don't go into to discover insights, you don't go into analyze data, you don't go into interpret KPIs or the likes. You just go in, you transform your data to useful formats for the end users to make use of. And that is the non-exhaustive list of what analysis engineering is about. Okay, so now here, the relevance of analysis engineering in today's age is mostly because a lot of companies have access to large amount of data in their data warehouse. That is the key concept. The key concept here is that companies have data and they are stored in their data warehouse, and they need someone to be able to make this data in the data warehouse useful and ready for end users to use. I always recall that the end users are the data analysts, why why you as an analysis engineer are the one who will go and prepare this data in that data warehouse for them to make use of. So an analytics engineer here acts as a link between data engineers and data analysts. For comparison, data engineers work on designing the platforms, which is the infrastructure of these platforms, right? And processes for analytics engineers to use. Analysis engineers then use these platforms and processes to clean, organize, and maintain data. And then our data analyst comes in and examines and interprets this data. So it's like a bridge. We come in, we bridge between the data engineers and the data analysts, because you're also going to be required to have good business domain, good business knowledge domain than the data engineer. And data analysts, they're all about business first knowledge, right? So you're here to come and bridge that gap. That is the core purpose of an analysis engineer. So to prepare data for data analysts and other key figures in a company, an analysis engineer engages in data testing, transformation, deployment of data models, and documentation. Now, this image here is just a simple representation of what an analytics engineer do from beginning to end. So they have this raw data which is being stored in a cloud platform, your data warehouse, your cloud platforms. And as they are stored there, they need to be given to the end users to make use of, but they are mostly stored in formats that the end users can't just pick up and start using. They have to be transformed, and by transformation, I mean this all these various columns in the data warehouse, they will be cleaned, and they will be named properly. They will be transformed in such a way that the end users can simply pick up this data from your cloud warehouse, pull it into their BI tool, and start making use of. So at the end, they are only picking out KPIs. They are picking out relevant information that is sent for them to make use of, and they are not going to spend their time within the data transformation and data modeling process. So over here, you have the DBT semantic layer, which I said DBT is a very important tool in analytics engineering. So the semantic layer simply refers to your transformation and modeling layer. And from there, you pass it on to your end users, which are BI tools, ML models, data scientists, and the likes. So analysis engineering largely involves building transformation pipelines and managing data models, building well-defined semantic models, and optimizing queries within your data warehouse. So queries have to be optimized in a data platform. So to optimize for cost. So cost is one of the major things when transforming data in a cloud warehouse. So on this note, does anyone have any questions to ask? Does anyone have anything to clarify? If you don't understand anything, please feel free to speak up so that I can clarify it for you. Okay, Mr. Osage, please. Osage, please. I hope I pronounced that well. You can speak if you have any question.
Good evening, everybody. Good evening, sir.
Good evening.
Okay, my question is this: before one can go into this analytics engineering, does that person has to be familiar with data analysis? Like, the person needs to know Excel, Power BI, and the rest before he can go into analytics engineering. That's my question.
Your foundation is SQL. Just that too. SQL. Nothing else. Forget Power BI. Forget Excel. You, that is a plus. Those are plus for analytics engineers. Your foundation is SQL. Nothing else, right? After building on SQL is where you start layering other tools like DBT, like a warehouse, like an orchestration tool, but your foundation is SQL, right? Now, in addition to SQL, you can add Python as a plus. Now, Python is a very big plus, especially when you start getting into a more advanced part of analytics engineering, because you get to start doing orchestration. But just write it on a note, SQL. That is just it. You know, SQL is a foundation. You may not know Power BI. You don't need to know it. You may use it once in a while, but you don't need to be so good at it. What you need to be good at to stand out is SQL. So I hope that answers your question. Mr. Tomiwa, please, you can ask your question. Hello, Tomiwa, I can't hear you. I don't know if it's just me, but we can't hear you clearly. Your volume is low. Yeah, we can try.
What about now, sir?
That is better.
Hello, hello.
Yes, that is better. That is better.
What I'm asking is that is it the platform you are talking about? Can you expatiate more on it? As in, because someone said PG admin like Postgres SQL can serve as our database, as in database where you query data from. So my question, sir. I don't know if you get me, sir.
Yes, I did. So I didn't want to come to this image yet, just so I don't cause trouble. But if you look at this now, this is a simple, this is a basic, this is a basic pipeline in you refer to PGAdmin, but if you know that PGAdmin, Postgres is more of a local database than a data warehouse. Now, in some companies, they may use Postgres within a, if you've ever heard of Superbase. So Superbase is Postgres in the cloud, right? It's literally just Postgres in the cloud. It doesn't really matter. It doesn't really matter if you're using Postgres, or the most popular data warehouses are BigQuery, Azure Synapses, and AWS. So within the three big cloud providers, AWS, Microsoft, and Google, they have BigQuery, they have Snowflake. Snowflake is another one. They have AWS Redshift, and they have Microsoft Synapse. Now you see this image here, where I have this. So this is referred to as your this is representing our data warehouse, and this is representing the data within that warehouse. Now you can literally have your Postgres and replace this guy over here. You can replace your Postgres with this guy. The idea is that you get the concept of pulling data from multiple sources. Your source might not be a Postgres, your source might be Shopify, your source might even be YouTube, your source might be Netflix, your source might be a SaaS platform, your source might be an ERP platform, or a CRM platform. The idea is that you pick up data from multiple places, right, from multiple sources, and you load them into a single point. This point here is referred to as your central storage. This point here is referred to as your central storage, where you get all this data stored in, and is often referred to as, I won't get into this, but it's often referred to as the raw layer. The raw layer simply means that you do not do any perform any transformation on at this place, right? On this guy here, no transformation is carried out, nothing. You just load this data into here, and that is it. You leave them inside there. Now, this is mostly where companies hire analytics engineers to work in. So they have their data stored in at this layer. It could be terabytes of data, it could be gigabytes of data. That is where you hear the concept of big data, right? They have a lot of data stored inside here, and they just want to make sense of it. They want their data analysts at this point to come up to be able to make sense of this data inside here. These guys over here, because these data analyst guys are the Power BI users. They're not going to pull large data from this source here. They're not going to do that. It has to pass through a process, which is the data transformation and modeling process. This is where an analytics engineer, like, say 70% of their work resides. Anything outside this is just you performing other tasks, right? This is where their role resides in. So this is also a layer within your data warehouse. Like I said, your data warehouse could literally be a Postgres database. As long as you understand the concepts of data transformation and data modeling, it still applies. So, Mr. Tomiwa, I hope that answers your question.
Yes, sir. Yes, I'm fully understand now.
Okay. So, who else have any question? It would be nice if you guys clarify one or two things before I move on. So, if you have any question, let me know now. Okay, so I'm guessing I can go on with the presentation. Okay, so I've passed it. So if I were to continue on this, like I was saying, this point here, this transformation point, this point here is 80% of an analytics engineer's work. Right? This is your role almost all through. Now, in most cases, you'll still be asked to extract from multiple sources, and that is where a lot of things have changed in the current landscape of data now. Now, in the past, in order to create ingestion pipelines, you need to know how to program a lot, like SQL or Python. That's where you hear data scraping, pipeline buildings, and the like, building pipelines. So any role that requires you to build an ingestion pipeline using Python, using SQL, those are largely data engineers' work. So, like I said, they build out this infrastructure, which is very code heavy, right? Now, with the advent of businesses, regular businesses that have access to their large data in a warehouse, you can just make use of platforms, SaaS platforms or no-code platforms to pull out data from multiple sources. Analytics engineers literally don't need to code their way. They mostly perform coding at the transformation part. But from here, you can pull out data from multiple sources. I've carried out a project before where I pulled out a couple of data from Shopify. So I had to create a store on Shopify, a live store, right? It was a dummy store. They allow you to do that. And then I was able to pull in data from Shopify into BigQuery just by using a platform. So most of these tools are largely cloud-based tools, cloud-based platforms. That is the most important thing you should take away within analysis engineering. Most of your tools you'll be using are cloud-based, right? If you use Power BI, you probably downloaded Power BI desktop. But if you're using BigQuery, you're not downloading BigQuery desktop. There's no such thing. If you're using DBT, there's also DBT Cloud, which is what most companies adopt nowadays. At least most companies in much more developed nations adopt nowadays. There's DBT. There's the open source version of DBT. So this here is DBT. There's the open source version of DBT, which is what you would use primarily to learn and to get started with data transformation and data modeling. But they are also cloud-based solutions for all this, from ingestion to transformation to your data warehouse to even your orchestration. Although orchestration, like I said, is more of data engineering. So this is code heavy. This guy here is code heavy. And then down to your visualization like Looker Studio or business or Power BI. So let's go on. So if you want to start learning analytics engineering, this is your primary tool that you would use for a start. Now, regular code editor like VS Code, your PC RAM has to be good, about 8 gig of RAM. A 4 gig might be acceptable, but to ensure that you perform well, you need an 8 gig of RAM upwards. You need Python installed because sometimes you may have to touch Python. Python is just necessary to learn along the side, but it's not primary. You need DuckDB. Now, DuckDB is a free data warehouse alternative that you can have installed on your system, right? It's an alternative to data warehouses like BigQuery or the AWS data warehouse. So instead of you going onto BigQuery where they will ask you to put in your what do they call it, your card for payment, because you definitely have to do that. They will not start billing you, but you have to put in your card. If you don't want to go through all those methods, you can just go ahead and install DuckDB on your system. It's a very light database that works in similar fashion as a data warehouse. For the guy that was asking me about Postgres, now there's one important thing that you should note is that Postgres stores data differently than a data warehouse. And DuckDB is the closest thing you can get on your local system that works as in the same way a data warehouse works, right? So if you get into learning this concept, you will understand this more clearly. And then optional, which I don't think you should focus on now, is Docker. So Docker is more of production level development than local level. So don't get too carried away with this guy, but just have it in mind that he's very important. He's a very important guy and a very stressful guy to get set up on your system. So that's why you should not bother with him right now. Okay, I think that is even the end of it. Yeah, that's the end of the presentation. So far so good. If you still have anything to clarify on, if you'd like to hear more about any parts of the presentation, please, you can signify and then I'll clarify on anything that you need to get, so you need to understand better. So does anyone have anything to ask or anything to add or the likes? Okay, so no one at all. So I'm guessing we've actually gone through a brief, like this is a very brief introduction to what analysis engineer is. Believe me, is more deeper and more interesting than this, right? So one, I could not prepare the slides in time because I have to go to work like from morning to night and just come back with the brief time I have to get this done. And two, I'm kind of exhausted right now, but I'm trying my very best to clarify as much as possible as I can to let you understand how much you can learn in this field and how interesting it is. It's a very interesting field, honestly. If you're interested in engineering parts of data analysis, these classes are for you, right? Is a no-brainer here. If you're interested in ever transitioning into data engineering, you would love to start from here, you know. And the reason why here is a better option is data engineering has a higher barrier to entry than this discipline. Unlike data analysis has a lower barrier to entry, but it also comes with the high saturation that you guys are seeing. So everybody already done Power BI and SQL and Excel. Literally every data analyst has done that, right? But when you now move forward into the advanced parts of now learning data warehouse concepts, learning cloud concepts, you literally just differentiate yourself from regular data analysts and the like. So it's a very interesting role. Come now, come the future. you know. And as we move in, as companies with little technical teams like data engineers move to want to make use of their data, especially at the AI and LLM levels, that analysis engineers will become more important and vital in in the few coming. It's already a vital role, right? It's just that the awareness is still on the increase. It's still growing gradually and gradually. It may not have blown up like AI engineering and the likes, but just know that it's a steady growing role, and it's something that people over the time will get to understand more of and get to request more of. So for you guys that are getting this, knowledge earlier on, before everybody becomes an analytics engineer, like a data analyst right now, it's like finding gold. Honestly, it's a very interesting career path and a very interesting discipline and domain. So with that, I think I've come to the end of this presentation. So I don't know who will take it up from here.
Yeah, I'll take it up from here. Thank you so much, Mr. Okezie,
Okay.
for this wonderful presentation. It's very insightful. You guys should actually appreciate Mr. Okezie now. It's not really been easy being here. Do you think it's easy to actually get this platter of course? And you can't get like to actually study this kind of course, you have to actually pay up to 6 figures in naira, man. People don't know what analytics engineering is. So the
I
fact that it's
know.
actually giving you this knowledge for free, people don't know how much it costs to go into whether data engineering or analytical engineering. They think that is something you can go and study online. They don't know how deep it is. So once again, Mr. Okezie, thank you so much for coming. If you have any other questions, please, just send it to me. I will actually refer all your questions to Mr. Okezie. Thank you so much. So, guys, thank you actually for your time. Thank you for being here. And we will see you when we see you. Thank you so much, everyone. Have a great night and a lovely weekend. Thank you so much, Mr. Okezie, again. We'll be looking forward to hearing more and also collaborating with you in the nearest future.
Thank you very much for having me here.